Good evening, everybody. We're just waiting for a few more people that are joining us. So those of you that are here, good evening. My name is Christina Medved and I'm with the Roaring Fork Conservancy. So thank you again for being here. If you wouldn't mind just giving us another maybe 30 seconds. I know some people are still joining us, and then we will go ahead and get started with the evening. Okay. So thank you again, everybody, for being here. If you have a moment, it would be wonderful if you wouldn't mind dropping me a little note in the chat box and letting us know how you heard about tonight. We're always trying to hear how the word gets out and how we can better improve our public relations for events like this in the future. So we're thrilled that you all are here. There's quite a bit of you on this call from all over the state of Colorado for monitoring mountain snowpack for water supply forecasting and beyond with Karl Wetlaufer. We're so excited to hear everything Karl's going to present about, and especially hear about our upcoming spring and summer river forecast. And so before I turn the evening over to Karl, I just wanted to give you a brief little introduction to Roaring Fork Conservancy, since there are so many people that are here from other parts of the state. So the Roaring Fork Conservancy is located in western Colorado, up in the mountains, and the section here highlighted in blue is the area of the focus of our work. And so the Roaring Fork Conservancy is soon to 25th birthday, if you will. So we've been in the Roaring Fork Valley for 25 years, and our mission is to inspire people to explore, value, and protect the Roaring Fork watershed. And we fulfill our mission primarily through our watershed science and policy programs, and that includes everything from water quality monitoring to engaging with stakeholders, and then also through our watershed education programs. And that covers everything from kindergarten through college age and adult and family programs. And I encourage you to go to our website to find out more information about those programs. So the thing about the Roaring Fork Valley, and those of you that live here are probably really familiar with this. This is an image of the Roaring Fork watershed, and it's about 1,400 square miles in size. It's roughly the size of the state of Rhode Island, and we have 3 major rivers in our watershed. The dark blue color is our namesake watershed, the Roaring Fork River, which begins near Independence Pass, flows through Aspen, makes its way through Basalt, and then Carbondale, and ultimately in Glenwood, where it flows into the Colorado River. And so the other 2 major tributaries here to the Roaring Fork are the Crystal River here, where you see my arrow, and then the Frying Pan River here. And the thing that I want to point out about this particular watershed map is that the darker orange colors signify higher elevations. And so the headwaters of our rivers, specifically in the Roaring Fork Valley, begin in really high elevation areas, mountains that are above 13,000 feet, 12,000 feet. We have 714ers in this watershed. And so snowpack is our predominant snow, I should say, is our predominant water supply. And so snowpack is something that we monitor on a regular basis. And so for those of you that might not be aware of this, we actually do release a weekly river and snowpack report, especially in the wintertime. In the spring and summer and early fall, it's just a weekly river report specifically. And we release that every Thursday, and we utilize data from USGS and the NRCS, the Snotel sites, to put the snowpack report together. And the summary box here is what we've been seeing within a matter of a week. And so we give you a nice little short paragraph about the patterns we're noticing, what we need to be aware of. And so if you're not already getting these in your emails, you could always respond to the email I sent out yesterday for this talk tonight and be like, please add me to that list, and we can email you those river reports every week. or you could go to our website on our news page and see those as well. So I just wanted to throw that out there in case you were interested in continuing to receive information more specifically to our watershed after this presentation. But without further ado, I want to go ahead and thank Karl again for being here. The Brookshire Watershed Institute, for those of you that maybe haven't attended before, is something that was started about 2 years ago, but it was like a 20-year idea from the Brookshire family. And the premise of it is to invite water leaders from the region, from the state, from the entire country, to talk about important water issues, and then how are we addressing some of these things in the Roaring Fork Valley, and especially to provide for the public opportunities for one-on-one dialogue with water leaders like Karl. And so I'm going to go ahead and stop my share screen here so that Karl can start his share screen. And I'm going to go ahead and introduce you to who Karl Wetlaufer is. So Karl is a hydrologist and assistant supervisor for the Colorado office of the USDA-NRCS Snow Survey and Water Supply Forecasting Program. He was born and raised in Western Colorado, spending time in the mountains and on the rivers of Colorado and around the West. Karl attended Montana State University and received bachelor's and master's degrees in snow science and snow hydrology. He has been working for the Snow Survey program in Colorado for 7 years. And so before I turn the microphone over to him, I just wanted to let you know we're really excited. Karl has told me this, that he's very excited to get your questions and have a great conversation with you all. So if you have questions, please put them in the chat box, and I'll be monitoring that tonight, and I'll be the one that will go ahead and ask Karl those questions, and we'll just go from there. Okay, thanks everybody. Thanks again for being here, and Karl, the stage is yours.
All right, thank you. Can everyone hear me?
Yes, we can hear you, Karl.
Okay, excellent.
Yeah.
Yeah, thank you, Christina, and thanks for everyone for joining us tonight. And yeah, like she mentioned, please feel free to enter any questions in the chat box, and I'm happy to kind of just address those as we go through and make this as much of a conversation as a presentation, if you guys would like. Yeah, I'm just planning on kind of going through a whole, not only just their current conditions, but kind of a history of snowpack monitoring in the West and how our snow courses and Snotel networks work, and then get into different ways to access the data, some of our more modern tools, and then our kind of current conditions and outlook for the spring and summer. Yeah, please feel free to ask questions at any time you would like. So just an overview of our office. We've fortunately recently got on some additional staff. There are 9 of us based out of our Denver office here, and we do all the snowpack monitoring for Colorado, Arizona, New Mexico, and Southern Wyoming. And then we do provide all the actual water supply information just for Colorado, but we monitor the sites in those 3.5 states basically, and I'll give a little bit more information on that as we go through. So as I'm sure everyone on this call is aware, and Christina mentioned, the vast majority of water supply in the West and Colorado in particular does come from the mountain snowpack. So that's the main reason we have our Snotel sites and snow courses, is for water supply forecasting, but the data these days really is used for quite a variety of things as well. So we're mostly known for snowpack monitoring, the snow water equivalent, which is basically if you were to melt a column of the snowpack, what that depth of liquid water would melt out to be. But we do monitor mountain precipitation and air temperature throughout the entire year, throughout the summer as well. And with that, we provide a variety of different monthly, daily products. We produce the actual volumetric Streamflow forecasts, but we'll kind of cover all that in more detail as we go through. So just a brief history of how we got to where we are. Basically, the fundamentals of Western snowpack monitoring started in the early 1900s. There was a actually a classics professor. He was a professor of literature at the University of Nevada, Reno, but always had a scientific interest, who wanted to develop a way to forecast the next summer's surface elevations of Lake Tahoe and the outflow of the Truckee River. And he actually took it upon himself to develop basically what we still use today as the modern snow course to measure the snow water equivalent, and started working on the fundamentals of how to use that data to forecast water supply. So we're really using very similar techniques. The equipment has changed slightly over time, but we're using a very similar technique as he developed back in the early 1900s. And then shortly after the Dust Bowl is actually when not only our agency, which has been through several names over the years, but the NRCS basically came to be to conserve soil resources after the Dust Bowl. And then shortly after the agency was formed, the federal government also recognized the importance of monitoring snowpack for future water supplies and fundamentally how that'll affect agriculture, but also municipalities and other important things across the West. So in 1934, there was federal funding provided to begin developing these snow courses and starting to monitor mountain snowpack in a consistent way all across the West. And this monitoring became operational in 1936, and many of our modern snow courses that we still go out and measure on a monthly basis are measured in the exact same locations and the exact same ways going back to the mid-1930s. So there's a really good long period of record of that snowpack data. And we're measuring down to, very precise areas, within several feet of taking each sample point. And I'll discuss exactly how those are measured here in a second. But yeah, basically mid-1930s is when the cooperative federal, state, and private snow surveys came to be. And they're called that. It's always been federally organized, but it's always been a cooperative program where people with a vested interest volunteer their time, their staff time, to go out and measure the snow and submit the data for us to compile. So just a quick overview of what a snow course is. We refer to these as manual snow surveys and snow courses. And it's basically a transect of commonly 5 to 10 points where we take a series of measurements, and we have tubes that we take a core of the entire snowpack, and then we actually weigh it to get what liquid water content would melt out of that snowpack. So if you're just looking at snow depth, depending on the density of snow, there could be a wide range of how much liquid water would be held in there. And so that's why we weigh it. It's kind of a simple method, but it still proves to work quite well to get at what the actual liquid water content would be. In Colorado, most of our snow courses are 10 points. So we take 10 cores and we weigh it to get what the snow water equivalent is. And then we take the average of those points is our end measurement that ends up getting put in our database and reported to the public. And those are measured on a monthly basis from the end of January through the end of April in Colorado. So that method of strictly manual measurements went on for about 30 years before we started experimenting with automated stations to record hourly data. And that started in the mid-1960s, but it took another 10 years or a little bit more until we actually were able to telemeter that data and access it in real time. During that period, staff would still have to actually go out to the stations and record the data, which then was recorded on paper scrolls, and now is kind of a more modern system that I'll discuss a bit later. But in the late 1970s, we started experimenting with telemetry to send out the data to be received through radio waves, through a radio-based system. And in the late 70s is when our current Snotel system became operational. So we started installing our modern Snotel system in 1977 to 78. And there was a big push then. Really, many of our sites across Colorado and across the West were in that first push of of the late 80s or late 70s into the early 80s. And it's really been this very similar structure since we started that. We've made quite a few different modernization efforts over time, but a lot of the basic parameters that we monitor do go back through that 40-year period of record. And just as how we install them, many do have replaced the manual snow courses over the time period, but many also are just installed from water supply forecasting needs, just general lapses in monitoring of mountain ranges, or for a specific request of needing a forecast for a reservoir inflow. So it's kind of a mix of where we decide to install them. So this is a quick look at what our office, which we're referred to as the Denver Data Collection Office, is our formal name. The region we monitor goes basically from Casper, Wyoming, all the way down to southern New Mexico and Arizona. We are responsible for 186 Snotel sites, 115 of which are in Colorado. And we have 8, I'll show a map in a little bit. We currently have 8 that we have in the Roaring Fork, and we're actually looking at possibly installing another one, generally upstream of Aspen, possibly in the Castle Creek drainage, but we're all actually are currently exploring options for a new site in the region. Solar Snotels are on the map on the left there, and then on the right, the light blue dots represent our manual snow courses, and the dark blue dots are the Snotel sites. So we currently have 95 snow courses that are manually measured on a monthly basis, in addition to the 115 Snotel sites. So here's a look at what is in the Roaring Fork, going from McClure Pass and then further up on the Crystal, North Lost Trail, and Schofield. We have 4 sites pretty high up in the Frying Pan Basin, and then Independence Pass, obviously up towards the pass, kind of up a side valley. We also have another site called Brumley, just on the far side of Independence Pass, just on the east side, right when it starts to flatten out. And we're kind of exploring another site in this region here, just generally south of Aspen. We're investigating several opportunities there for an additional Snotel monitoring station in the Roaring Fork Basin. So every Snotel site in the network measures 4 basic parameters, and that is the snow water equivalent. So again, that is if you were to melt a column of the snowpack, what the depth of liquid water that would result from that would be. And we measure that and report it to the 1/10 of an inch level of accuracy. We measure total snow depth, and then from that you can get the snow density if that's a parameter of interest. We measure total accumulated precipitation, and the primary way we report that is just accumulated throughout the entire water year, which starts on October 1st. But we also do provide information on a variety of different parameters, daily, monthly, a variety of different things, but primarily we report the total accumulated precipitation as both snow or rain, naturally hail, any form of precipitation, and also air temperature. In addition to the standard sites, so every single snow site in the network, which is, I want to say in the range of 860 across the West and Alaska now, has those 4 data parameters. But many others also have soil moisture, soil temperature, other things like relative humidity, wind speed and direction, as well as solar radiation. And all of these enhanced sensors, we are hopefully trying to improve that over time and steadily increase the number of sites that involve these, what we call enhanced sensors, both for our own data, the public, but then also to help drive different modeling efforts to help improve not only just modeling the snowpack across space and time, but also the actual hydrologic modeling and how that influences stream flow. So this is a look at a pretty standard looking Snotel site. They're always or not always, but we generally try and locate them in forested areas, but in a small meadow. And the primary reason for that is to minimize the effect of wind redistribution. So if it's in a forested area, it reduces the potential for large wind events to affect our data, and kind of falsely imply that there's more or less snow in the general area just because of a wind event. So they're generally in small to medium-sized meadows. Then going around here, what my mouse is circling right now is one of our primary sensors. This is noted as the SWE pillow. We call it the snow pillow, and that's where we get the snow water equivalent from. And basically what it is a 10-foot diameter rubber pillow filled with fluid. And it works fairly similar to how our snow course measurements work, in the fact that we're basically weighing the snowpack. You can almost think of it as a large scale where we're weighing the snowpack, and then we can get a measurement of how much water equivalent would melt out. So this is plumbed, it's full of fluid, and it's plumbed into our instrumentation shelter here. And the more weight of snowpack on that forces fluid out and up a vertical tube in the shelter. And then we have a pressure transducer in there that basically weighs the fluid inside of that tube. And that gives us a direct measurement of how much snow water equivalent is on the pillow. Then over here on the right, we've got our storage precipitation gauge, which works in a very, very similar manner. It's just an open system that, again, is plumbed into the shelter. And the elevation of fluid that accumulates in the precipitation gauge is always going to be the same in the gauge as in the shelter. You can think of it as basically a large U-shaped pipe where they're always at the same elevation, and then we just measure the pressure head inside of the shelter, and that gives us our inches of precipitation. Then here on this tower by the snow pillow, over the snow pillow, we've got our depth sensor, which I'll go into a little more detail about exactly how these work in a bit, but there's our snow depth sensor, air temperature sensor on there. And if we have the solar radiation, wind sensors, sometimes it can be variable on which tower they're on. They're not in this picture, but then near the shelter, we've got our radio antenna for data telemetry, as well as our solar panels, because all the sites are obviously in very remote areas and independently powered by solar. So again, I went over this briefly, but here's kind of another look. This is a picture of a newly installed snow pillow over here. And then this is what it looks like inside of the shelter. Again, we run plumbing and 1/2-inch tubing under the ground, which is protected by PVC pipes. Then it goes up this, we call this the manometer tube. So again, the more weight of snowpack pushes down on the pillow, it pushes this red fluid higher up in there. And then it's measured by a pressure transducer, and that gives us the inches of water equivalent that are sitting on the pillow. Then our snow depth sensor, how they work is it is an acoustic sensor. So it emits a series of clicks. If you're on site, you can actually hear it. Just goes click, 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 click. And it measures the amount of time for that sound signal to bounce off of the snow surface and return to the sensor. And then it's able to calculate what that distance is. And from that, we can kind of back calculate what the depth of snow is, just knowing what the zero value of bare ground is. Based on that time it takes for the sound to go down and back, then we get the snow depth. And then also there's this little cylinder on the bottom, which is a temperature sensor. And that allows for an adjustment based on the air temperature, because colder air is a little bit more dense. And then the sound signal travels slightly faster. So that does help us get the most accurate measurement we can. For our precipitation gauge, again, very, very similar to how the snow pillow works, but instead of exerting pressure and forcing fluid out, it's just an open system. So however, whatever the elevation of liquid in the precipitation gauge is, it's going to be the exact same in our manometer tube in the shelter. And then we have this pressure transducer that's basically weighing that amount of fluid inside the shelter. And that provides us how many inches of precipitation have accumulated throughout the year. The air temperature sensor is fairly straightforward. The sensor itself we call a thermistor. And then what you actually see, this white thing is it's a gill shield, but what it is a radiation shield. So the measurement is less affected by direct sunlight. It protects the sensor itself from receiving direct sunlight. And then it has the gills to allow air to flow freely through it to get the most accurate measurement we can. So as I mentioned, all the sites are completely powered independently by solar, or 99.9% of them at least. And our standard telemetry system for sending the data out that we have used since the late 1970s is called a meteor burst radio. And this is changing swiftly. We are pretty swiftly moving towards using cellular modems and satellite telemetry. But our traditional system, which is still most of the network, or at least more than half of it, basically uses that big antenna and sends up a radio signal into the atmosphere, and it bounces off what we call the ionosphere. When meteors enter the atmosphere, they burn up, and this radio frequency actually reflects off the ionosphere and then comes back down and is received by two master stations near Boise, Idaho, and Salt Lake City. So traditionally, all our data is bouncing off this layer in the atmosphere and just received by these two independent stations across the West, and then integrated into our database from there. But again, there are a lot of advantages, and we are swiftly modernizing to different telemetry techniques. So who uses Snotel data? It's really a constantly expanding group traditionally, and we really still are currently funded, and our primary focus is for water supply forecasting. But everyone from just recreational users, backcountry skiers or snowmobilers, to people in the recreation industry planning the next season of how rafting or fishing is going to go, to the National Weather Service for their weather forecasting, avalanche centers for their avalanche forecasting, just private water users, municipalities. It's really, really a wide range of folks who rely on the data these days. So just an overview, some important stuff to know as you're looking at the data. The vast majority of Snotel sites do put out 24-hour reports a day. Some we shorten that reporting level to make sure the batteries don't die if for some reason they don't get a ton of sun or something like that. But the vast majority do put out 24 reports a day every hour. We do have automated data trapping methods. So if there's obviously erroneous data, that becomes unavailable to the public. So if you're looking at snow depth, for instance, it's pretty common during storms for the sensor to be interrupted. So if you're looking at a table of snow depth and there's missing data, that's because it's been flagged as what we call suspect, and blocks that from the public. And then our most official data set is we only have personnel edit daily data, which is always going to be the midnight value. So that's what we consider our most official data set. During our 24-hour data, you'll commonly see some small fluctuations, but our daily data is what actually gets reviewed and manually quality controlled by staff. So there's several different ways to access Snotel, Snow Survey, water supply data. The two primary ways, at least here in Colorado, is we have a local NRCS Colorado Snow Survey page where we produce a lot of the standard kind of static maps and graphs that I think most people are most familiar with. And those are produced both daily and then more detailed information on a monthly basis. We can combine both Snotel and snow course data for the Snowpack information. as well as compile all of our water supply forecasts. So there's really a lot on there. I want to say we probably produce 30 or 40 more different daily products, just different types of maps and graphs to analyze the data for your needs. So worth exploring. And you can just, to access this, if you just Google Colorado Snow Survey or something similar to that, it'll take you right there. There's really a lot to explore. The other main way to access snow survey data, in particular if you're looking at regions all across the West, is through our National Water and Climate Center website, which is basically our programmatic headquarters. And the National Water and Climate Center also hosts our actual forecast hydrologists. So here in Colorado, we're primarily responsible for collecting and quality controlling the data. And then we actually have a separate team that runs the water supply forecast models and actually produces those. And we work very interactively with them. As well as a variety of things, but they currently host, not only have links to the state web pages, but also host a wide variety of our more modern products, which I will kind of cover here. I think one of our most exciting products that I think is really great for everyone to know about, and it's kind of a one-stop shop for all the data that we host, from snow, reservoir, precipitation, the water supply forecast is our new interactive map. And we've recently even added several new updates to it, where not only you can look at individual Snotel site data, but different types of basin summaries and at different spatial scales. You can look at change over time of snow water equivalent, depth, precipitation, many different metrics. As you can see, I think I have another slide that shows even some more of them, but you can look at rankings and percentiles, how it compares to the period of record, really a ton of different metrics, as well as, I'll show you here real quick. And in addition to being able to just color code, and you can put labels on what the percent of normal is for snow or precipitation, you can click on additional sites, and that provides more statistics as well as links to a variety of different tables and graphs. And we recently have also added the capability for a basin. So for instance, if you wanted a basin summary of conditions for the Roaring Fork particularly, you could, if that was displayed as a basin summary, you can click on it and then it'll open up all these different maps or different graphs and all sorts of different statistics. So I think that's really one of our most powerful new tools, and I'd strongly encourage everyone to check it out. There's a lot of different ways to analyze the data. So this is just kind of zoomed in, but I wanted to add this in just as an example of the different elements you can look at. Again, snow data, precipitation reservoir, stream flow forecasts, as well as past observed stream flow. So at the end of the season, you can look at how things really panned out compared to the period of record. And then just a ton of different statistics you can plot on the map. Tons and tons of different ways to look at the data. So really a lot to explore, and I'd encourage people to use that tool because it's we found it to be very useful for us as well as the general public. Another function of the interactive map is you can download a CSV file, basically an Excel document of all the statistics you're looking at. So whatever you're plotting, not only visually on the map, but the Excel file that you download has all available statistics on it. So if you're looking for a deeper analysis of the conditions, or you want to sort and analyze how many sites have record highs or record lows, you can easily do that using the CSV export function. And the one other thing I'll mention is, don't think I have an image of it, but in the top center of the map view, we also have a export function that'll export kind of just a higher quality, more cartographically correct map if you want to use it in a presentation, post it in your office, anything like that. And I've got some examples of how that looks. But in the top center, instead of just having to take a screenshot, you can also download a higher quality map for more of a presentation view. Another good kind of one-stop shop that I still really like, it's a bit of an older product, is what we call our daily update reports. And these are available on the National Water and Climate Center website as well, on the menu on the left. But it provides just a really quick overview of both basin and station conditions. So it's just got a different section where it gives you the basin, the average of conditions in the basin, which is currently reported as the percent of median, what we call the normal value. And then also if you're interested in just individual sites. And these are available with more specific information for precipitation as well. This has snow water equivalent and water year precipitation. We have different reports that show month to date precipitation, but it's just a good quick overview of what's going on in a given basin or individual sites. So the report generator is, I would say, one of our most powerful tools. It's arguably a little less user-friendly to kind of find exactly what you're looking for. But basically, this is a way to access period of record data. We offer in this element box more information on basically different statistical parameters that aren't available elsewhere. You can search for individual sites, or you can pull up sites by state or by county, or really a variety of different ways. But in addition to Snotel, we do have our reservoir data, Streamflow data, and you can pull it up on daily, monthly, hourly, any time step you want. But if you're really looking to dig into information, or in particular looking for full period of record, you can access it through this report generator. And in addition to the National Water and Climate Center homepage, you can access this data through the interactive map. If you click on an individual Snotel station or snow course, there will be links to pre-made tables and charts through here for you to look at. And it's also a good way to kind of just start looking at the data, and then you can modify it from there, add sites or change the time period, anything you would like. One of our most official products that is available primarily through our local Colorado Snow Survey website, but also through the National Water and Climate Center, is our monthly water supply outlook report, which we just recently released our most recent one. And it is kind of our best one-stop shop for our most official information, I would say. We've got data that combines both our monthly snow course and daily Snotel data to get the most accurate snowpack picture, our official monthly water supply forecasts, reservoir precipitation, and it's about a 40-page PDF document, and we've got our own custom written summaries and maps and graphs. And if you're interested in this, you can sign up to get email notifications on our Colorado Snow Survey website for whenever we produce this official report every month. Some of our other products that we've been producing for a long time that folks are likely familiar with are these static maps and graphs that we produce on a daily basis. And most of these are going to be derived from just Snotel data, since that's available daily. But we do also have more official monthly products that include Snow Course and Snotel. But these are all available through our Colorado Snow Survey website. Another exciting product that I've really liked and has been getting good reviews, and I recommend checking out, is what we call our interactive charts. So the products I just previously mentioned are all just as a static image, and some of them compare to different periods of record and compare to different years, but those are kind of chosen by us or automatically chosen. And this is a really cool product because it allows you to compare to any year of interest. So a lot of times it can be very useful to compare to a year that just comes to mind. If it's, say it's a really dry year and you wanted to just real quick see how does this compare to 2012 or 2002, over here on the right, you can just click and see how it compares to any year in the past, if that is useful, just anecdotal evidence, as well as maximums, minimums. There's a little X that kind of shows where the usual peak amount is. And we have these available for not only all major basins, but many smaller sub-basins. So we do have this available for the Roaring Fork specifically, using those 8 sites that we currently have. And this is available from both the National Water and Climate Center homepage, as well as our Colorado Snow Survey homepage. We have these what we call the projection plots, both available as our traditional standard products and as the interactive part. And basically, they describe, based on percentage probabilities, what the range of outcomes of the remaining year could come from. So it'll plot either both the snowpack or water year precipitation up to the current date, and then has different percentages, the probabilities of exceedance, basically, of how the rest of the year might pan out, just based on the historic record, what's been observed in the past. But as both the winter and summer progresses, it kind of gives you just that range of possible outcomes of what to expect, if that helps with any water resource planning. So getting into our water supply forecasting a little bit, which is the result of basically all this snow and precipitation data we produce. Some important things to know: they are all for what we call naturalized flows. So we do calculations for changes in reservoir storage and diversions, transbasin diversions, removals from canals, any data we can get. So we're basically trying to forecast for what would come down the river if it was a natural, unimpaired system or unimpounded system. Our most official forecasts, as we call them, come out on a monthly basis, and they're more closely reviewed by our forecast hydrologists. But we also do have daily guidance forecasts that are produced on an automatic basis, strictly based on observed Snotel data, but they can be a good resource for just seeing how things change throughout the month between our official forecasts. So if it remains dry or we have a big storm system, those automated daily guidance forecasts provide a good idea of what you can expect throughout the month and how that helps your planning. There are the other major entity that does water supply forecasting are the Noaa National Weather Service River Forecast Centers. So the most relevant for a lot of folks on this call, I'm imagining, would be the Colorado Basin River Forecast Center. And they also do the seasonal volumetric forecasts. So how much water is going to come down the river from April through July. And they also do shorter term 10-day outlooks. And that's largely with concern to flooding and such, but that is another good resource for water supply information in addition to the NRCS. So we currently have 90 different streamflow forecast points in Colorado, and my apologies, I didn't update this to the current data, but I do have that information coming up in future slides. But again, this is a screenshot of our interactive map, kind of the more formal output that we provide, but a good way to access not only the actual water supply forecasts, but observe streamflow data and a number of other parameters. So I won't go too much into the weeds, but our current forecasting method is what we call a principal components multiple regression. But it's basically a regression model where we use a historical period of record and compare our observed monthly precipitation and current observed snowpack and make correlations between that and what the resulting runoff was. So for the most part, we try to keep a minimum of 20 years of period of record before we implement, trying to implement these correlations. But that's, for the most part, what we're doing is comparing observed snow and precipitation to what the resulting runoff was the following spring. And then we run statistics on that and do our best projection of what the future runoff will be through the April through July period. So we offer this information in a variety of formats. One of the classic one is a table that gives a range of outcomes similar to the projection plots. All of our forecasts are based on different probabilities. So commonly we'll speak about what we call the 50% exceedance chance, which is kind of the most likely. But in this product, it shows, you can see here on the bottom, here's the Roaring Fork for this year. But this middle value in the green here is kind of what you can think of as the most likely, but we have different probabilities of occurrence of different flows. So that can help you judge as you go through the month or go through the winter. If things get more wet or more dry, you could say maybe, oh, it's going to err towards this 30% chance of exceedance. So it gives you the range of likely outcomes instead of just one static value. And you can kind of use that as a guidance depending on how future weather holds, because really aside from model uncertainty, one of the biggest sources of uncertainty in any streamflow forecasting scenario is just simply future weather that you just can't control. So these are a great tool. And I don't have the entire image on here, but down at the bottom, we do have a bit more of an explanation of what you're looking at, as well as this gray vertical line is basically shows what average runoff is. So this would be 100% of average. And then the colored bars here are our forecasts. So in this year, the fact that this whole bar is to the left of the gray line basically indicates it's very unlikely that the Roaring Fork or the Colorado down lower would achieve an average streamflow runoff volume. This display is of what our daily water supply forecasts look like. And this actually is a current image for the Roaring Fork. So the yellow boxes display our official monthly forecasts. So you can see there is a pretty notable difference between these automated forecasts, just what we call, again, our guidance, versus our official forecasts, largely due to snow course data being integrated, but also difference in the models. But it still gives a good idea of how things change. As an instance here, there's a large precipitation accumulation at the beginning of February, which showed an increase in the forecasts, and then conditions dried out. So we're estimating the forecasts dropping. But again, it just shows good guidance of generally what's likely to happen in between our official forecasts. Another newer thing that we are offering is forecast verification. So at the end of the snowmelt runoff season, you can go to the interactive map or those charts that I just showed with the colored bars, and it'll show you how the forecasts actually panned out, basically how accurate our forecasts for the previous spring were, if that may be of interest for anyone. And there's basically on the charts just kind of one bar, a simple look at it, and then on the interactive map, there are a variety of different statistical metrics that you can use to analyze how well the forecasts panned out. And similar to I mentioned for Snotel with our forecast points, you can also click on them and get a pop-up window with a lot of the different summary statistics just right there without having to populate them on the map if you're interested in just one particular forecast. So lastly here, I'm just going to kind of give an overview of where we're sitting now, kind of our current conditions. As of today, statewide snowpack is 85% of normal. And again, we consider that the percent of median observed snowpack. And it has fortunately become more tightly constrained across the state, from a low of 79% of normal in the southern San Juans to a high of 100% of normal just to the east in the Rio Grande, and all others between really in that range of loosely 80 to 90% of normal snowpack. So it's not the greatest we've ever seen, but it is certainly an improvement over what it was earlier in the winter. Oops, and looks like I did not update the precipitation there, so my apologies on that. I will skip ahead and I can gladly pull up our current precipitation in a little bit, but generally it is our water year precipitation since October 1st is lower than what we observe in snowpack due to a dry late fall season. But really the biggest take-home point for this season that is important for everyone to consider is that in addition to our current water year, the summer and early fall was extremely dry. We entered the winter with a pretty major drought, and because of that, soils have been very dried out. So we are expecting lower runoff volumes than we commonly would in a year with a similar snowpack, and that is definitely reflected in our Streamflow forecasts, which we'll take a look in a second. But that's really one of the biggest take-home points is how we entered fall and winter with very dry soil conditions. We're expecting that to impact our runoff next year. So here's zoomed in on the Roaring Fork. All the dots here labeled are the local Snotel sites within the basin. So a bit of variability, a bit better snowpack up here in the Frying Pan. A couple of those sites actually having above normal snowpack currently, which is good to see. And then in the southern half of the basin in the 70 to little over 90% of normal range. And the net snowpack across the Roaring Fork being 88% of normal currently. So here's looking at a summary of our actual volumetric streamflow forecasts in the upper Colorado. Some of the ones that are most relevant to the Roaring Fork Basin, Rudai Reservoir inflow is for 72% of average. And again, we're looking at the total volume from April 1st through July 31st. So that primary snowmelt runoff season. And then it's a slightly lower, down lower, the Roaring Fork at Glenwood Springs is for 66% of average. And I'm guessing that is a little bit lower just due to some of the lower snowpack in these more southern Snotel sites. And then the Colorado Cameo, kind of one of our main outlet points for the state, is for 63% of average volumes. So here is our current water year to date precipitation, which my static map before was not updated, but this is the current data. So you can see, like I was noting, that it is lower than the current snowpack. It's currently 76% of average water year to date precipitation, as well as all of the individual site data being considerably lower than what we observed for snowpack due to that dry conditions in the early fall. And that is all of what I have for a presentation, and I am happy to take any questions that anyone has. And again, thank you all very much for taking your time to attend, and I hope that was valuable.
Thank you, Carl. Lots of interesting information, lots of really great slides explaining how the Snotel sites work. And while people are adding their questions into the chat box, I did just want to give a plug real quick. Roaring Fork Conservancy and NRCS staff from the Glenwood Springs office is leading a tour of one of the Snotel sites in our watershed, the one on McClure Pass, tomorrow. And I still have a few spots available. We are limiting participants to 8. And I think I have 3 or 4 more spots available if you're interested in attending. But go ahead and register tonight. And the nice thing about this is that you will get an opportunity to see the inside of a Snotel site and be able to ask questions. You're going to be able to dig a snow pit. We do have one of the snow tubes that we'll be using as well. So you'll get to participate with the NRCS Snow Surveyors just alongside them and be able to do a little bit of your own forecasting as well. So take a look at our website for any of that information. So if there are any other questions, I'm not getting any questions here yet, Carl, but I have a question for you, if that's all right. Can you hear me okay?
Yes, yep.
So a question I have for you is you had mentioned in the beginning that you all are considering adding a Snotel site to the Castle Creek Valley. And I was curious, how many new Snotel sites are added a year, or maybe it's every few years? And how do you all decide where to put one? The newer ones that you are thinking about adding?
Yeah, that's a great question. It's been a couple years since our office has installed a new site, and that has honestly largely been due to staffing numbers. But now that we have more staff on board, we are hoping to ramp that up. On average, I'd say it might be, out of our office, has been one new site per year. And it's kind of a combination on local requests, if there's a specific need, our own identification of just lack of representation of a given mountain range and basin. And we also work with the water supply forecast hydrologists on analyzing what areas might be able to use more monitoring to improve the accuracy of the water supply forecasts. So it's really kind of a combination. A lot of times it does come from a request from local water users if there's a particular need, but sometimes it is just internal, and we generally do work with our forecast hydrologists on determining what'll help maximize the efficiency of that data for us and to the public.
Okay, thanks, Carl.
Yeah, of course.
You have a question from Steve Hunter. Steve is asking, first of all, he says, thanks, Carl. Is the NRCS looking at integrating any of the ASO program?
Yeah, we actually recently have been having more discussions with ASO, and there's actually a kind of a Colorado cooperative group that is trying to work to integrate to maximize the effectiveness of any ASO data that is collected in the state. This group was actually kind of initiated by Denver Water, but it's got a bunch of vested interests across the state to try and figure out how we can maximize the utility of that. And Steve, yeah, please feel free to reach out to me on the side if you're interested in being looped into that group. So it's kind of in its infancy, but we are having those conversations.
Carl, can you remind us what ASO stands for?
Yeah, so it's the Airborne Snow Observatory, and it is basically a high resolution measurement of snow depth that they do from an aircraft using lasers. And then they have models of snow density that they get the snow water equivalent from. So it is limited in how many basins they can cover in a given time period. But yeah, it's just an extremely high resolution measurement of the snowpack throughout a basin.
Okay, thank you. Okay, so we have a question from Lori. Can you talk more about the radio telemetry solution that uses meteor trails? Very cool, she says.
Yeah, it's interesting, and it still honestly fascinates me to be out in the field and look up at a clear blue sky and picture it bouncing off meteors that burned up and ending up in Idaho and Utah and actually being received. But basically, a lot of people think about meteors or meteorites as the ones you can see burning up, but there's really just millions of particles bombarding the atmosphere every day and burning up. And basically, the instant they burn up, it creates what you can think of as a surface that this particular radio frequency will reflect off of. So at the top of the hour, every hour, our radios start trying to transmit the data. And when they get an adequate meteor trail to reflect off of, and that data is received at our master station, the master station gives an immediate response back to the remote Snotel site that the data was in fact received, and then it stops trying to transmit until the next hour. And the top of the hour, it just tries, and most of them can get the data through in about 15 minutes. Probably 85% of them will try for 15 minutes or less before it's able to get the data through to the database. But it is
So cool.
It's kind of a wild system, and we're the only one in the world that I know of that actually uses it, and it's kind of just due to the unique nature of our remote sites that it works out and is practical.
That is pretty cool. Okay, thank you, and thank you, Lori, for the question. So we have another question from Grayson. Have you seen a decrease in groundwater levels? And is there a site that has information on this for the Upper Roaring Fork Valley?
So our Snotel sites monitor shallow soil moisture. Any site that monitors soil moisture, all of them have sensors at 2 inches, 8 inches, and 20 inches, and some go all the way down to 40 inches, but we don't necessarily monitor any deep groundwater. And I actually got this question a few days ago, and I couldn't dig up the best resources for like the greater groundwater picture in a basin, but I will think about that, and I can follow up if I think of anything. But yeah, all of our sites just monitor more shallow soil moisture conditions. But we have observed, both from our data and observations from others and just being out in the field, that the surface soil moisture conditions are extremely dry right now below the snowpack. And that's why we are anticipating the observed stream flows to be lower than they commonly would with this amount of snow that we have, even with the snow being below average. But with how dry the soils are, they basically have to absorb a certain amount of moisture before they start transmitting that water that melts through to a stream channel.
And Carl, I also am not familiar with a resource that monitors groundwater levels, but I will, I'm going to ask Steve Hunter, who's on this. I think he's still on here because he may be familiar with a resource. He's a hydrologist that works for the city of Aspen and worked for the White River National Forest for a long time. I don't know, Steve, if you happen to know of a groundwater resource for the Roaring Fork Valley, that'd be awesome if you could share. You're welcome to unmute yourself. But the other thing I wanted to add is the Aspen Global Climate Change Institute, AGCI. If you were to Google them, they are monitoring soil moisture throughout the Roaring Fork Valley, but I don't know how deep their sensors are. And so I don't know if Elise is on this call or somebody else from AGCI that can maybe answer that. But again, I don't know. There's Steve. Maybe Steve, hi Steve, maybe you have a resource to share with us.
Yeah, AGCI, I believe, and if Elise is on the call, she can correct me, but I believe they are at 2, 8, and 20 inches. So once again, shallow groundwater, or soil moisture, excuse me, not groundwater, soil moisture. I can follow up with both you and Carl. I think there's some stuff, but yeah, unless you're doing an individual mod flow model for a particular area, I don't know if there's a resource you can go to other than something on the USGS, but I can follow up with you and Carl on that to get something on the website if it's available.
Thank you, Steve. I appreciate that.
Yeah, and one other good resource is the Colorado River Basin Forecast Center that I mentioned. On their website, they do have their modeled soil moisture, so you can, it's not a very fine spatial resolution, but they do produce what their modeled soil moisture conditions are that they use for their forecasts. And our folks work with them, but you can look at a map of the entire Colorado River Basin to get at least a general idea of what their modeled forecast is, as well as the Colorado Climate Center and what's called NIDIS, I think it's the National Integrated Drought Information Center, has bigger picture drought information and possibly soils data as well. But those are some good other resources for at least a general idea of what's going on.
The other thing I just did in the chat box for people that are interested is I did add the name of the Aspen Global Climate Change Institute and the Colorado River Basin Forecast Center that you can look up. But I also added a link to the Snowpack page on our website, because we have direct links to some of the graphs and maps that you showed, Carl, but also to some of the other resources that you talked about tonight. So you can, it's all direct linked there. So just go to the Snowpack site that I just sent out on the chat box, and then you'll find all those resources. They're easy to find there. And you're always welcome to email us at Room for Conservancy for any help finding those things. I don't have another question for you in the chat box, but I'm wondering if maybe you could answer a different kind of question for us. Because it sounds like, well, you have been with a Colorado Snow Survey for quite a few years. I'm wondering if you could tell us a story about some of the deepest snow that you have had to measure in a snow course, and maybe also the opposite. Like, can you tell us of a place that you went to that you were just like shocked at how little amount of snow there was? So looking for kind of extremes here, some fun stories from the field.
Yeah, definitely. Well, the deepest I measured actually wasn't in Colorado. I actually started with the Idaho Snow Survey. And up in the North Fork of the Clearwater, they actually do some helicopter surveys to really remote areas. And I measured some that were 15 to 16 feet deep. And not only measuring it with our snow tubes, but it's kind of crazy to be in those Snotel shelters, the brown building, because we've got a ladder inside and you actually crawl down to the bottom. And when it's that deep, you can just like feel, it's an interesting just feeling to feel like you are just in the snowpack. That, you know,
Wow.
the snow surface is 10 feet above your head and you can just almost like feel the pressure around you.
Whoa.
In Colorado, I don't think I've probably measured more than 7 or 8 feet, but it's a wild experience measuring those really deep snowpacks in North Idaho.
And do you still use a snow tube when it's that deep? Like, how do you do that?
Yeah, you still use the same snow tube, and for really deep, dense snowpacks, there's actually a slightly different style tube that's easier to drive to the bottom. But then you actually have to use 2 people. It's quite an effort. 2 people have to both grab it and just do a 1, 2, 3 and just try and use momentum to get it all the way to the bottom before it gets stuck. Sometimes you actually have to, you can put a handle on it and you have to actually jump on the handle to drive it all the way through to the bottom. So it's definitely a lot more challenging. And our colleague who's based out of Reno and in the Sierra Nevada, sometimes he'll measure a 25-foot deep snowpack. It's really dense, and it'll take him like an hour to be able to drive it to the bottom to get one sample point.
All right, Carl, next time you join us for one of these presentations, we want pictures of those sites, okay?
Okay, yeah.
Well, let's go ahead and close out tonight then, because it doesn't look like we have any more questions unless, Carl, there's something else that you want to bring up. But I do want to thank you so much for your time and for you sharing your expertise with us tonight. I want to thank everybody for joining us tonight. I just want to remind you, actually, I don't think I told you this in the beginning, but this presentation is being recorded and it will be available on our YouTube page by the end of this week. And I will email everybody the link and how you can find that. So, Carl, thank you again. I don't know if there's anything else you want to add in closing.
I don't think so. I think really the big picture for people watching for our water supply this spring is that fact of how big of a drought we went into winter with, and we are looking at some really dry soils. So both our forecasters, and we're hearing it from the National Weather Service, are anticipating, you know, if in a normal year our snowpack was 100%, the Streamflow would likely correlate with that, but we're expecting Streamflow to maybe be 15% or so lower than our snowpack. So when looking at things, I'd keep an eye on the forecasts in addition to just the snowpack is really the big practical take home. But yeah, I don't think I have anything else. And yeah, thanks to you, Christina, and the Roaring Fork Conservancy, and thanks for everyone for joining.
Yeah, definitely. And, you know, for those that are interested in staying tuned to all of this, please do sign up to receive our weekly snowpack and river reports, because we do pay attention to all of these things that are coming out of Carl's office and Noaa and the National Drought Information Center. And we do try to add some of that content to the summary that we write every week. And as Carl said, I just want to reiterate, like, people are concerned. Everybody's concerned about the below average snowpack, what that's going to do with flows. I do want to tell you that the firefighters are also concerned. I heard that in January, people that our local fire folks are concerned, and it isn't just local, it's across the state. Now it's also, I'm hearing across the West, that firefighters are already prepping for what could be a busy season. So pray for more precipitation. Definitely. Thank you, Carl. Thanks again, everybody. Have a great evening. And
Yep. Thank you, everyone.
Bye.